Logarithmic and exponential models. We're going to have word problems of situations that can be modeled by an exponential function. There will be an example of exponential growth and an example of exponential decay. We'll start with exponential growth of an insect population. The size p of a certain insect population at time t in days obeys the model p of t equals 500 times e raised to the 0.02 t. Question A. Determine the number of insects at t equals 0 days. So we are simply going to evaluate p of 0 by substituting 0 in place of t in the given equation. Now we know that multiplying anything times 0 is 0. We know that anything to the 0 power is 1. So here's my answer, which I really should include in sentence form because this is a word problem in context. So let's go back to what we were asked to determine. And let's write a sentence. Initially, at t equals 0 days, there are 500 insects. So the number 500 that is in the given equation, that is called the initial amount, in this case of insects. Problem B, what is the growth rate of the insect population? So with these problems, there will always be a rate either of growth or decay. The rate will be the exponent of e, the number that is multiplying the t in the equation. And my growth rate here is 0.02, but we want to write it as a percent. So the growth rate of the insect population is 2%. Because remember, I move my decimal point 2 to the right to convert a decimal to a percent. What is the population after 10 days? Well, similar to part A, we're going to substitute t for 10 this time. And we're going to simplify this expression. To multiply any decimal by 10, I just move the decimal point 1 to the right. And at this point, I do need a calculator. I want to evaluate e raised to the power of 0.2 and then multiply that by 500. Here's where we write our answer in sentence form. After 10 days, the population of insects will be about 611. Part D. When will the insect population double? So I'm looking for t. I want to substitute into my given equation everything except the t. If I started with 500 insects, then p of t will be 1,000. And notice I have just the one variable left. It's up in the exponent of e there. So to isolate the variable t, let's divide by 500 to both sides. Let's simplify our equation. And here, to get to t, I want to take the natural log of both sides. And my right-hand side becomes 0.02t. To get t alone, I want to divide by 0.02. And this is the place where I need a calculator. I type in natural log of 2, divide that by 0.02, and I get about 34.7. Once again, I write my answer in context. The population of insects, right, is expected to double in approximately 34.7 days. So that was an example of exponential growth. Now we'll look at exponential decay. And the prompt says, strontium-90 is a radioactive material that decays according to the function given, where A sub 0 is the initial amount present, and A is the amount present at a time t in years. Assume the initial amount is 500 grams. What is the decay rate of strontium-90? So once again, we look to our given equation and we see that the decimal that's multiplying the t up in the exponent is negative 0.0244. So the negative indicates decay. I'm going to move my decimal 2 places to the right The decay rate of strontium-90 is negative 2.44%. How much strontium-90 is left after 10 years? I'm going to evaluate A of 10. And I'll substitute the 500 in place of my initial amount. And I'm going to simplify this expression, multiplying my decay rate by 10. I just moved the decimal one place to the right. I do need a calculator at this point. I want to evaluate e to the negative 0.244. Multiply that by 500. And double check that my answer makes sense. If I started with 500 grams, after 10 years, I am expecting less. I have less, so let's write our answer in context. After 10 years, there'll be approximately 391.7 grams of strontium-90 remaining. Question C, when will 400 grams of strontium-90 be left? When the prompt asks for when, I'll be solving for t. So I need something in my given equation for every variable except t. So my a of t will be 400. My initial amount is still 500. My rate is given. And here I want to get t by itself. Let's start by dividing both sides by 500. And let's simplify this. Now let's take the natural log of both sides. My right-hand side will become negative 0.0244t. And my left-hand side, in exact form, is natural log of 0.8. Let's divide by that coefficient of t. And at this point, I use a calculator. And I get approximately 9.13. Does this make sense in terms of my context? Well, it should make sense because part B, it said that after 10 years, there's 391 grams remaining. Part C is saying after about 9 years, there's 400 grams remaining. That does make sense. So we're going to write down our answer. 400 grams of strontium-90 will be left in about 9.13 years.